Welcome to Physics World Online College for Simplified Physics, where we make the concept of physics simple and clear for you to understand and also to excel in your exams. In our class of today, Physics 101, we will look at vector product or cross product. This is a follow-up on our last class, scalar product or dot product. In that class, we multiply two vectors to obtain a scalar quantity. In this class, we will multiply two vectors to obtain a vector quantity. Now, we say the vector product or cross product of two vectors A and vector B is expressed as A cross B. Now take note, the pronunciation is pronounced as A cross B. So this is not times, this is A cross B, that is vector A cross vector B. Now, the magnitude of vector A cross B is expressed as the magnitude of the cross product of A and B is given as, you know, when we say magnitude, we use this absolute sign to represent magnitude. So this is magnitude of A cross B. Is given by the magnitude of A, the magnitude of B, sine the angle between the two vectors. Let's call this equation 3. We had equation 2 in the last class in case 2, where absolute value of vector A means the magnitude of vector A, magnitude of vector A, and this is the magnitude of vector B, magnitude of vector B, while this is the magnitude of A cross B, magnitude of vectors A cross B. Angle theta is the angle between the two vectors, A and B. So if the angle theta is 0 degree or 180 degree, then if you do sine 0 or sine 180, it gives you 0, which means 0 multiplying magnitude of A, magnitude of B, giving us what? 0. What does that mean? That the cross product of two vectors A and B will give you 0 if the two vectors are at angle 0 degree or 180 degree. That means vector A and B, the two vectors, are parallel vectors. They are parallel to each other. If the angle theta is 0 degree or 180 degree. Then the vectors A and B are parallel vectors because sin theta, which is 0, is 0. Likewise, sin 180 is 0. So we say such vectors are what? Parallel vectors. Now, the implication of that is their unit vector A and B. The unit vectors of A and B, I, J, and K, are also what? 0 to each other. So we say note that I cross I, J cross J, and K cross K is equal to what? 0. So the unit vectors are 0 once the two vectors are parallel to each other. So if in a question they say proof that vector A and B are parallel vectors, it means show that you cross vector A and cross vector B together. Find the magnitude. If it gives you 0, you know that they are what? They are parallel to each other. If the angle theta, if the angle theta is 90 degree, then the vectors are A and B are perpendicular, or orthogonal to each other. What does that mean? Because sin 90 is 1. If you put sin 90 here, sin 90 is 1. What you have is that A cross B is equal to what? AB. So we are having that the magnitude of A cross B is equal to what? Magnitude of A, magnitude of B. This gives you a maximum value. So the implication on the unit vectors of A and B is this. To explain that, let me put it in this format. We have 3 unit vectors, I in the x direction, J in the y direction, K in the z direction. All 3 of them are mutually perpendicular to each other. They are at 90 degrees to each other. So they are what? Mutually orthogonal to each other. Now, the anti-clockwise direction is taken as positive. The anti-clockwise direction is taken as positive. What is the implication there? It means, observe what I'm going to do. If I do I cross J, I cross J, it will be equal to K. If I do J cross K, it will be equal to I. If I do K cross I, K cross I, K cross I will be equals to what? J. While the clockwise direction is taken as what? Negative. Watch out as well. So this is unit vector I in the S direction, unit vector J in the Y direction, unit vector K in the Z direction. They are all mutually orthogonal to each other. They are all mutually orthogonal to each other. The clockwise direction is taken as what? Negative. The clockwise direction is taken as negative. Now, what is the implication of that? It means if I do, I'm moving in the clockwise direction now. If I do K cross J, K cross J, K cross J will give me minus I. If I do J cross I, J cross I will give me what? Minus K. If I do, lastly, I cross K, I cross K, I cross K will give me what? Minus J. Now, if you look at these two, you will observe something. Let's take this first one. This is what? K cross J, giving me minus I. If you check K, if you check J, J cross K here, give me I. Now, you will see that it's as simple as saying I interchange the position. If you interchange the position of a vector, if you reverse the direction of a vector, you will put what? A minus sign. So if you look at this, this is I cross J equals K. Here now, if I interchange it to be what? J cross I. J cross I, it will be what? Minus K. So anytime the vector, the direction of a vector is reversed, a negative sign is what? Is put together with the what? With the value. Now we will establish a general example we will use to solve cross product of two vectors. Let's consider a general example. Let's consider two vectors A and B. Let's consider two vectors A given as ASI, AYJ, AZK, and vector B given as BSI, BYJ, and BYK. To find the cross product between vector A and B. Now, how do we answer such a question? To do that, we say vector A cross B. To do that, we say vector A cross B will give us, so solution to the example, we have A cross B. Take note, in vector, order is very important. When they say vector product between A and B, A must come first before B. If you do B cross A, you will not get the same answer. So A cross B means ASI plus AYJ plus AZK cross BSI BYJ BZK. Now we expand what we have, and that will give us that A cross B. You have to be very vigilant in this expansion. You give us AXI to multiply BSI BYJ BZK. Then AYJ to multiply BSI BYJ BZK. And lastly, AZK to multiply BSI BYJ BZK. Now we'll open the bracket. This gives us that A cross B equals AS times this. BY will give us AX BX I cross I. So the unit vector will cross each other. Plus AX BY I cross J plus AX BZ I cross K. The next term we have plus AY BX J cross I plus AY BY J cross J plus AY BZ K cross J cross K. And we have plus A Z B S K cross I. And we have A Z B Y K cross J. And lastly, A Z B Z K cross K. Now, we are going to add and use this relationship between unit vectors that we have established. What does that mean? We said where the two vectors have parallel unit vectors, I cross I, J cross J, K cross K, it is equal to what? 0. Where they have perpendicular unit vectors, we will put their corresponding equivalents. So what does that mean? Where I have I cross I, that component is 0 automatically. Where I have J cross J, that component is 0 automatically. And where I have K cross K, that component is 0 automatically. What I'm left with, I have vector A cross B is now equal to, this component is 0 plus AX BY I cross J. I will check I cross J is what? K. I will replace it with what? Vector K. Plus I have ax bz I cross k. I cross k. I have I cross k is minus j. So I put minus j here. Plus I have a y b x. J cross I. J cross I. Check for my j cross I. J cross I is minus k. So I put minus k there. Plus, this component is 0. Plus ay bz. I have that j cross k. What's j cross k? J cross k is I. So I replace it with I. And then I have plus a z b x. K cross I. What is k cross I? K cross I is j. I replace it with j. Plus I have a z b y. A z b y is in place of k cross j. K cross j. K cross j. K cross j is minus I. Minus I. And the last component there is 0. So let me believe that no component is left. So k, j, j, and then I. Okay. All right. So next we have that vector a cross b is equal to, this gives me ax by k. This minus will affect this plus here. Here is changed to minus now. Ax bz j. This minus affect this plus. Here is now minus ay bx k. And then this will give me plus ay bz I plus az bx j and minus az by j. So I will bring all the unit vectors that are similar together, starting from the i's. So I have vector a cross b equals, where are the i's? I have this, so I have ay b z I. And then I have this minus a z b y I. So I'm rearranging. I follow by j. I have my j plus ay bz j, no, is az bx az bx j minus ax bz j, next by k. So I have plus ax by k and minus ay bx k. So what I've done simply now is to rearrange, bringing the like terms close together. So now I can factorize it, the unit vectors out. I can factorize the unit vector out. That will give me a cross b is equal to AY BZ minus AZ BY in bracket I plus I have AZ BX minus AX BZ in bracket J. So I have plus AX BY minus AY BX in bracket K. So you can see the answer I've obtained. I still have the unit vectors in my answer, which tells me that the what? Resultant is what? A vector. If you cross two vectors, you obtain a vector. Now, I want to confirm that what I have arrived at is correct. So I'm going to compare this with what I have here. So A cross B equals AY BX minus AZ BY in the direction of I, that is correct, plus AZ BX minus AX BZ in direction of J, that is also correct, plus AX BY minus AY BX in the direction of K, that is correct. So I'm very much correct with my derivations. Now is for us to apply what we have to solve specific examples. We use it to solve specific example, and then you will do the assignment thereafter. So let's take the example, solution to example. Solution to example. So we are given vector A as 3I minus J plus 3K. And we are given vector B as minus I plus 2J minus K. If we compare this with the general equation, it means our AS is what? 3. Our AY is minus 1. Our AZ is what? 3. Why? Also comparing, it means our BZX is minus 1. Our BY is 2. Our BZ is what? Minus 1. So I will simply quote this equation for cross product and then substitute the value. So we say, but A cross B is equal to AY BZ minus AZ BY I plus AZ BX minus AX BZ J plus AX BY minus AY BX K. So we substitute the values. We have that A cross B is equal to AY is minus 1 times BZ is minus 1 minus AZ is 3 times BY is 2. Everything in I direction plus our AZ is 3 times our BX is minus 1 is minus 1 minus our AX. AX is 3 times our BZ is minus 1, or in the J direction, plus our AX is 3 times our BY is 2 minus our AY is minus 1 times our BX is minus 1, or in the what? K direction. So we multiply out, we have A cross B equals minus 1 times minus 1 is 1, 2 times 3 is 6, that's minus 6i, plus 3 times minus 1 is minus 3, minus at the center, that is also minus 3 in the J direction, plus 3 times 2, that's 6, and then this is minus 1 times minus 1 is 1, that is in the K direction. So this will give me A cross B is equals to 1 minus 6 is minus 5i, plus 3 minus 3, minus times minus is plus, plus 3j, plus 6 minus 5, that's what? 6 minus 1 is 5, that's 5k. So we have therefore A cross B is equals to minus 5i plus 3 minus 3 is 0, 0j equals to, or plus 5k. So we can simply write it as minus 5i plus 5k. This is 0j, and that will go away, disappear. So our final answer, you can see there is still unit vector there, minus 5i plus 5k. So you still have a vector. That confirms that if you do the cross product of two vector, if you do the vector product of two vector, you will get what? A vector quantity as the resultant. Please kindly attempt to this assignment, solve it, and post your answer on the comment section. In the next class, I will give an alternative method for finding or doing cross product or vector product. Please watch out for that class. Bye for now.